Hello everyone, I'm Sharmila Trinavakarasa from Bharatdasan University. In this video, I'll explain about laser beam welding. Plan of the talk is about laser beam and its property, what is welding process, principle of laser beam welding, types of laser welding, that is micro laser welding and deep penetration welding, its advantages and disadvantages. First of all, let us start out with the basics of laser. The term laser means light amplification by stimulated emission of radiation. A laser beam is an electromagnetic radiation which is powerful, monochromatic and directional. A laser device excites the atom in a lasing medium. That is, the electron of these atoms move to a higher energy state and then release photon when they return to the ground state, thus creating a laser beam. Properties of laser beam. A laser beam is highly intense in nature, is monochromatic, is highly powerful and capable of propagating over long distance. It is not easily observed. It is also said to be highly directional. It is also coherent. That is, the waves which are coming out of the lasing medium will be in phase with one another. What is welding process? This happens when a laser beam falls on the surface to be melted. That is, the surface absorbs a part of the laser radiation in a short period of time and the material starts to melt. This leads to welding process. Here, either the surface of the material or the laser beam can be moved relative to each other. This can be achieved through the following phases. First one is the interaction of laser beam with the work material. Second one is the heat conduction and temperature rise, and third step is melting, vaporization and joining. These four diagrams symbolize the laser welding process. In the first one, the observing material is present at the bottom and the transmitting material is overlaid upon it. In the second one, the material is irradiated by the laser. That is, the laser light is converted to heat at the boundary surface of the material, causing the material to melt. During the irradiation, the transmitting material is also melted due to thermal conduction, and finally the material is cooled and solidified to form a bond. Next, let me explain about the experimental setup of laser beam welding. Here, the laser can be in the form of solid state, liquid state or gaseous state laser. Right now, this laser belongs to the category of solid state laser. Here, ruby crystal is used for making the light source, and these crystals is surrounded by a flash lamp. This flash lamp converts the electrical energy into light energy. The ruby crystal is made up of aluminum oxide with chromium dispersed throughout it, and silver coated mirrors are present at both the ends of the crystal, one which is 100% reflecting and the other is partially reflecting. And also a capacitor is provided in order to store the electrical energy and supply high voltage to the flash tube for performing appropriately. So by this partial reflecting mirror, all the rays that are from the particular light source, it will be passing through in the form of beam towards the lens. With the help of this lens, the beam is concentrated onto the material, that is the working area. So, highly excited light source is concentrated on the area and it will be generating a heat, and due to that heat, welding is carried out. What I explained now is shown below. A laser beam is produced inside the ruby crystal. It is made up of aluminum oxide and chromium which is dispersed throughout it. A flash loop is provided. Electrical energy is converted to light energy. Capacitor is provided for storing the electrical energy. Finally, a narrow beam is focused by the lens to produce an intense laser. Laser beam welding is of two types, that is micro laser welding and deep penetration welding. Micro laser welding. There are various configurations in micro laser welding such as butt weld, lap weld, center weld, wire to ribbon weld, T-weld, cross ribbon weld, end weld, plug weld, etc. These configurations have been successfully achieved using lasers with several dissimilar and similar metals. The mechanism of micro welding can be explained by the heat transfer. In the welding process with low power lasers, the surface of the workpiece absorbs the laser energy and this energy penetrates into the material through thermal conduction. This imposes a limit on the penetration depth. This depth can be increased by the use of continuous wave mode lasers, but then the process becomes slow and the heat spreads to more areas. NdArc, CO2, Ruby and Nd glass are some of the lasers used in low power welding. Ruby and Nd glass have comparatively low rates of pulse repetition and hence with these lasers it is easier to do welding by overlapping the spots. However, it is a slow process. NdArc and CO2 laser can be used in the continuous wave and pulsed modes. Both pulsed and continuous wave lasers operate at several hundred watts of average power, which is suited for seam welding. At an average power of 100 watt, a pulsed laser performs like a continuous wave laser, emitting several hundreds of watts. This happens due to high pulsed peak power, which breaks down the reflectivity of the surface, which results in the laser energy being absorbed more efficiently. Low power lasers can be successfully used for welding of uranium vessels within thin tubes. Wire joints can be welded to make interconnection. These lasers can also be used for welding hardware used in space vehicles having high temperature bearings, electronic sensing packages, etc. Micro laser welding has proved to be successful in intricate works like welding of thermocouple wires inside a thermocouple gauge head, welding of bearing assemblies, etc. Next one is the deep penetration welding. In this process, the laser that can deliver laser power in multi-kilowatts in continuous wave modes are used. Deeper penetration is possible with these kind of lasers. The laser beam gives energy to the surface of the workpiece more rapidly than it can be removed by thermal conduction. As a result, vaporization takes place and there will be a building up of high pressure by the vapor which is partially enclosed and then the adjacent molten region gets pushed to the side. This permits the laser beam to generate greater depths into the material through the vapor hole of low density. So, there occurs an equilibrium stage between the pressure created in the hole and the molten bed. This determines the penetration depth when either the workpiece or the laser beam moves relative to each other. Molten metal flows behind the hole and gets solidified and the weld is created. Such a laser has a great depth to width ratio. This is called deep penetration effect or keyhole effect. And the results of high power welding is similar to that of electron beam welding. Still, laser beam welding has many advantages over electron beam welding. They are: the laser beam welding can be transmitted through the atmosphere or through various gases without excessive attenuation, whereas the electron beam suffers from this disadvantage because vacuum is essential for operating electron beams. With the laser, tooling is rather simple. In laser devices, mirror can deflect the laser beam close to the focal point. Next, advantages of laser beam welding. Narrow, precise, and accurate welding is possible. No filler material is required. It is also possible to start or stop the welding instantly. These lasers does not have any physical contact with the workpiece and hence contamination of the weld does not occur. This laser welding process can be carried out in normal workshop environment. It can be used to weld tough metals like quartz, titanium, etc. It can work with high alloy metals without any difficulty. No secondary finishing is required here. It is extremely accurate, high quality welds are obtained. Then disadvantages. It is of high maintenance cost, high cost for equipment, optical surfaces of the laser are easily damaged. The weld penetrations, which is larger than 19 mm, are difficult to weld. Rapid cooling rate may also cause cracking in some metals. So these are all the disadvantages which is involved in laser beam welding. Thank you.